Hi everyone. Uh, can anyone please confirm whether I am audible or not? Can someone please post in the comment box whether I am audible? Okay. Can someone confirm whether I am audible? Let me see. Okay. So in today's video, we will be talking about an interview problem, which is searching in a rotated sorted array. Can someone confirm whether I am audible? Can someone confirm whether I am audible? Okay, fine. So, hi everyone, myself Rajat Rawat, and in this video we will be talking about an interview problem which is searching in a rotated sorted array. So, first we will discuss about the problem statement. about what exactly the problem is, and then we will talk about the approach to solve that problem. And this problem is asked in many companies like Amazon, Facebook, and Apple. So we will start the discussion about this problem, and then in the end we will discuss about its time and space complexity analysis. So let's jump onto the problem first. Okay, so let me share my screen. Is my screen visible? Okay, so uh, let's discuss this question. So the question is, this is the question: searching in rotated sorted array. So the problem statement is like this: Ahad and Harshit always have fun by loving solving problems. Harshit took a sorted array consisting of distinct integers, and it is rotated in clockwise by unknown amount. So it is saying that there is a sorted array which is consisting of distinct integers. So all the integers are distinct and it is rotated in clockwise fashion already. So the array is already rotated in clockwise fashion. Okay, we will discuss about it, what exactly it means. So for example, he took a sorted array. Suppose this is the input sorted array 1, 2, 3, 4, 5. So the array is sorted first of all, and the inputs are distinct, and it is given that it is rotated by 2 clockwise. So what exactly is means by rotated by 2? So let's see for this example. So suppose you have 1, 2, 3, 4, 5, and it is given that rotated by 2. Okay, and in the clockwise manner. Okay, so clockwise it means that it will be rotated like this, from right to left, clockwise. So first, in the one rotation, 5 goes to the front, so it will become like this. Here it will become 5, 1, 2, 3, 4 in the rotation 1. Okay, so here 5 comes in the front in the first rotation. This is a clockwise rotation, and in the second rotation, 4 comes in the front of 5, so it becomes like this, 3. Okay, so this is the after two rotation. So this is the input, original input. After the first rotation in clockwise manner, it becomes like this: 5 comes in front, and after the second rotation, 4 comes in front of 5, so it becomes 4, 5, 1, 2, 3. Okay, so it becomes like this. So this is the uh, new input which is given to us. Okay, so this is given like right 4, 5, 1, 2, 3. So if the given input is this and rotated by 2, then the array becomes this: 4, 5, 1, 2, 3. Now it is saying that after rotating the sorted array, Ahad needs to answer Q queries asked by Harshit. Each of them is described by integer Qi, which Harshit wanted him to search in the array. So there will be Q queries, like they will be given with a number, and you want to find out whether that number is present in that rotated sorted array or not. For example, for each query, if he found it, he has to shout out the index of the number. Otherwise, he has to shout -1. So it is saying that if in this rotated sorted array, this one, rotated sorted, this one, okay, in this, if suppose you are given a number 5, and if that number 5 is present in this array, this rotated array, then you have to tell its index. So its index is 0, 1, 1. So you have to return 1, that 5 is present at index 1. And if that element is not present, then you have to return -1. Suppose in this is the input, and you are asked to find 6, and 6 is not present in this, so you have to return -1. So this is the second thing. Okay. So for each query, you have to complete the given method where key denotes qi. If the key exists in the array, return the index of the key, otherwise return -1. Okay, so this is the question. Suppose let's take the sample input. This is the input. The array size is 4, and the array's elements are 2, 5, -3, 0. Okay, 2, 5, -3, 0. Let's see this. Okay, so input is 2, 5, -3, 0. Okay, and the question is, the query is this: you have to find out whether 5 exists in this rotated array or not. Okay, so first query is this: 5. 5. First query is whether 5 exists. Okay, so 5 exists. This is 5, and its index is 0, 1, 2, 3. Its index is 1, so it exists at index 1. Okay, and next query is 1. Okay, so you have to find out whether 1 exists or not. 1 exists or not. So 1 does not exist in this. Okay, so you have to return -1. Yeah, that's it. Okay, so you are given an array which is rotated. Okay, and then you are asked some queries like in this form, and a number is given. You have to find out whether that number exists in this array or not. If it exists, you have to return its index. Otherwise, if it not exists, you have to return -1. So this is the question. Okay, so if you have any doubts up to this, then you can ask in the comment section. Okay, so let's move forward. Okay, so this is the second sample input in which 5 elements are given, and you have to find out whether 100 exists here or not. So here 100 exists at index 0, so 0 is returned. Next, 6 exists or not. So here 6 exists at index 2, so 2 is returned. So like this. Okay, so this is the second sample input. Okay, so till now, you have any doubts? Okay, fine. Let's see the approach first. Now we will discuss the approach to solve this question. Okay. So the problem is you are given an array and you have to search an element in the array. Let's take this example only 25 minus 30, and you have to find whether 5 exists or not. Okay. So one possible approach to solve this question is you search for each element in the array and compare it with the target element which you need to find. And if that element exists, then you have to return its index. Else you return minus one. Like you need to find whether 5 exists or not. Okay. So first what will you do? You will compare 5 with 2. Okay. Now 2 is not equals to 5. So you go to the next index, which is 5. Index 1. Now here 5 is equals to 5. Okay. So it means that you found out the target in the array. So you just return this index, which is 1. So you return this index 1. Okay. So in this 5 exists, so you return 1. Next, for 1, suppose you need to find 1. In this, first you compare with 2. So 2 is not equals to 1. So you go to next index, which is 5. Index 1, element 5. Now 5 is not equals to 1. So you go to next index, which is 2. Now 3 is not equals to 1. So you go to next index, which is index 3. Now 0 is not equals to 1. So you go to next index, which is index 4. Now you reach to the end of the array. It means you scanned all the elements and still you are not able to find out that element in the array. It means that element does not exist in the array. So you just simply return minus 1. So this is nothing but a simple linear search which you have done in this problem. Okay. So you have done simple linear search. One by one you searched for each element in the array, and if you found out that element you just return its index, else you return minus 1 if you hit the end of the array. Okay. So this is the first approach. This is the approach 1. This is the brute force, you can say, or yes, the naive approach, in which we use the linear scan. Okay, we just scan the array one by one, scan the array elements one by one, and if that element exists, then we will return its index, else we return minus 1. So its algorithm, let's discuss its algorithm. So in this, we just make a for loop which is iterating the whole array. I is equals to 0 to array dot length minus 1. Okay, we just iterate the whole array, and if that element double is equal to target, this target is given to you. Okay, that which element you need to find. For example, the target here is 5. So if array of I is equals to target, you just return that index I. Okay, that's it. And if you if you comes here outside for loop, coming here means uh, if you didn't reach to this line return I, and you reach to this index, this outside for loop, it means that that element does not exist in the array. Then in that case you return minus 1. Okay, you return minus 1. Why? Let's see this by dry running this for the above question. Okay, so first you need to find out 5 is present or not. Okay, so we will scan the array one by one. First we will go to the index 0. 0, at index 0 we have 2. 2 is equals to 5. 2 is not equals to 5. So this line won't hit. Now it goes to the for loop again. Next is 5. 5 is equals to 5. This is true. 5 is equals to 5. So this will hit this case, and it will go to the next line, which is this return I. So I is returned. I is the index at which you are currently present, and you are at index 1. So 1 is returned. Okay, and that's it. Control goes out from here. So it means that you return 1 and the element exists. Now suppose you need to find out the target, and the target is, let's say, 1. Okay, yes, so let's say the target is 1. Instead of 5, now you have 1. Okay, so okay, now 1. So you first scan the array one by one. First 2 is there, So 2 is equals to 1, which is false. 2 is not equals to 1. Okay. So it means you again goes to the next element of the for loop. Next is 5. 5 is not equals to 1. So you go to the next element of array, which is minus 3. Now minus 3 is not equals to 1. Again you go to next element, which is 0. 0 is also not equals to 1. So it means that you go to next and you hit this. So you reach the end of the array. And now after reaching end of the array, you just break out from this for loop. The control comes here, return minus 1. So minus 1 is returned. So in this way you have searched the element in the array. So the time complexity of this is, so at worst what you have done, that element is not present in the array. So you need to scan all elements. Scan all elements. So it means you have to scan each element one by one. And suppose there are n elements, so the complexity is order of n, where n is the number of elements in the array. Okay, this is the time complexity. And since you are not using any extra space, so the space complexity boils down to order of one. Okay, you are just using variables apart from, that's it, variable I and returning. Okay, so the time complexity is order of n and space complexity is order of 1. Okay, so this is the first thing which you have done. Okay, uh, now let's code this problem for the linear search. This will be really easy. So you have to scan the array. uh, the array here is, name of the array is ARR. So you are just scanning the array. Okay. Now for each element, you have to find out whether it is equal to target. To target here is key. Okay. So if means you found out that element in the array, you just return that index. Okay. Else you return minus one. Sorry, not else. You return minus one. Okay. So for each element you scan in the array. Okay. And if that element is equal to the target, which is the key, then you return that index of the element, because here it is written that you have to find out the index of that element. For if he found out, you have to find out the index of the number. So if that element exists, then you have to return the index, as you return minus one. So let's submit this. So okay, so it is giving TLE. Okay, so why it is giving TLE? Because the test cases are high here, 10 to the power 6 and 10 to the power 9. Okay, because there are 10 to the power 6 queries, and for each query there are 10 to the power 9 elements. It means that, okay, so it means that there are 10 to the power 6, like for one first you have to find out 5 exist or not, then you have to find out 2 exist or not, then you have to find out 1 exist or not, then you have to find out 10 exist or not. Like this there are 10 to the power 6 items which you need to find out one by one, and in each of these iterations you are scanning the whole array, and in the worst case the array size is 10 to the power 6. Okay, so if you multiply this, that each time in each finding each element you are doing 10 to the power 6 iterations for the first item. Okay, and you need to do this for 10 to the power 6 times, because we have to find out 10 to the power 6 numbers, one for 10 to the power 6 times we have to find out. Okay, so this will be 10 to the power 12. So this will give you time limit exceed, because max rate will be 10 to the power 8, which can be done in 1 second. Okay, so and it is exceeding 10 to the power 8, so it is giving you time limit exceeded error. So that's why it is coming TLE. Okay, so now we have to find out the optimized approach for this problem. Okay, so till now if you have any doubts, then you can ask in the comment section. Ashish, what you are saying long, we have to return an integer here in the array, and the test cases they are all in the range of integer. So we don't need to declare any long variable. It's giving that it is TLE because the approach is order of n, and I told you that there are 10 to the power 9 elements in the array, and in each end you have to do this 10 to the power 6 times. 10 to the power 6 into 10 to the power 9, so it is giving 10 to the power 15. That's why it is giving TLE. Okay, because the algorithm is taking to order of n time, and you are not asked to take this much of time. That's why it is giving TLE. Okay. Okay. Fine. Let's discuss the optimized approach now. Okay, so let's take the input. The input is 2, 5, minus 3 and 0. Okay, so the input is 2, 5, minus 3 and 0. Okay, so now we are discussing the approach 2 to solve this problem, the optimized approach. Okay, so the question says that the array is rotated sorted array. Okay, previously it was sorted, but then it was rotated by some amount. So what we see here, see, this is the rotated array. Okay, now if we see, there is a one property of rotated array is that at least one of the part of this array will be sorted. Like here in this case, it is completely like you can say that this part. Sorry. So here this part is sorted 2 to 5, and then this part is sorted 3 to 0. So if the array is rotated, then there is a property of the rotated array is that at least one of the parts of the array will be sorted. So here suppose you have two parts. One part is this one which is sorted, and next part is 2 which is this one sorted. Okay, so at least one of the two parts will be sorted, but here both are sorted. Okay, let's see another example whether this is true for another or not. The example is 100 minus 2, 6, 10, 11. So see this here, if you see this part is sorted, minus 2, 6, 10, 11. Okay, and 100 is unsorted because it is the largest number. So you can see at least one of the two parts in the array. So here how the two parts is coming in this, one is 100 alone and another is minus 2, 6, 10, 11. So this is one part and this is one part, and this part is sorted, right? So here also you can see at least one of the two parts is sorted. Okay, so so at least one of the two parties sorted. Similarly, like this. Okay, another example here another example is 100. So here only one number is given. So if the number is one only, then it is already sorry. This is the query actually. These are the two test cases which you can see. Okay, so the thing is, if the array is rotated, then the property is that at least one of the two parties sorted. Like here I told 2, 5 is sorted and minus 3, 0 is sorted. So here both the parts are sorted. Here 100 is one part, and then minus 2, 6, 10, 11 is another part. Okay, and minus 2, 6, 10, 11 is sorted. 100 is unsorted, you can see. So at least one of the two parts is sorted. Okay, now so from this we can get an intuition that even if the array is rotated, still there is one part which will be sorted. So if there is a part which is sorted in the array, and if you get that thinking that there is something which is sorted in the array. With the sorted, you can just realize that what we can do, what approach we can use if the array is sorted. So if the array is sorted, we can use binary search approach, because if the array is sorted, then we can easily find out that element in that sorted part. Okay, in that sorted part, and with that we can do it in order of log n, because we have to just find out that element exists or not in that part. Because whenever a sorted comes, then in your mind definitely binary search need to come. Okay, so let's see how we can use binary search for this problem. So let's take this example: 100 minus 2, 6, 10, 11. Okay, 100 minus 2, 6, 10, and 11. This is the input. Here this part is sorted and this part is unsorted. Okay. Okay, so let's see how we can do. So let's index this 0, 1, 2, 3, 4. Okay. So first of all, what you do, you don't know which part is sorted and which part is unsorted. Okay. So let's take the middle first. Okay, let's take the middle. How you can take middle? Start plus and index by 2, or you can use start plus and minus start index by 2. You can use either of these two, but it is advised to use this one so that integer overflow won't come. Okay, because suppose if both the s and e they are large numbers, then in that case this will be overflow and this won't overflow. Okay, so let's take the start index is 0, so let's see 0, and index is 4, 4 by 2, this will become 2. So it means that the middle element is having an index 2. Okay, this is the middle element. Now this is the middle element. Okay, now what you can do by finding out the middle element? Now you can see, if we see that, if we compare this middle element value with the start element value, this is the start, this is the end. If we compare this middle element value with the start element value, let's compare. Start is 100 and middle is 6. Now if the middle is greater is less than the start, here middle is less than start, right? It means that this part will definitely not sorted, because if this part is sorted, then in that case this element at index 2 must be greater than element at index 0, right? Because sorted says that it needs to be in increasing order. Okay, so, and if this part is increasing order, then definitely the element at index 2 must be greater than or equals to element at index 0. Okay, so this is the fun intuition which you can do. By finding out middle element, you just compare with the start element value, and if the middle element is less than, it means that this part is not sorted. Okay, as you can see, this part is not sorted. Now let's compare this middle element with the end value. Okay, so middle element and end value we need to compare now. So middle element value is 6 and end element value is 11. So 6 and 11. Now compare these two. 6 is less than 11. Then it means that definitely this part it will be sorted. Because if 6 is less than 11, okay, then it means that this part will be in the increasing order. And as we said that one of the two parts in the array will be sorted. And if you are getting the middle element is less than the end value, then definitely means that this part will be sorted. Okay, so this is the first thing which you need to do. If you need to find out the middle element. Okay, now but you don't know which part is sorted, because this is not a sorted array, but this is partially sorted array, means one of the two parts will be sorted. Okay, so what you do, you compare with the middle element with the start element, and then you find out whether left part is sorted or right part sorted. So here 6 is less than 100, definitely this part is not sorted, so you ignore this. Okay, next 6 is greater than 11, less than 11, so definitely this part sorted. So now you find out this part is sorted. Okay, now you can find out the target element in your sorted part. Okay, now you can find out this in the sorted part. Now let's see how you can find out in the sorted part or unsorted part, wherever it is present. Okay, let's see. Let's say you need to find out target is equals to 11. Okay. Now, so first, what you need to do? You need to find middle. Middle you find out 2. 2 is 6. Now you searched 6 is less than 100 or less than 100. So it is definitely this part not sorted. 6 is less than 11. So definitely this part sorted. Okay. Now you need to search your element in both the parts. In your this part left as well as in right part. Okay. Let's see. Why both the part? Let's see this. Because suppose the element 11, in this case it is present in the sorted part. It might be case that it is not present in the sorted part. It must be present in the left part also. Okay, let's see this. Let's see whether that first the case is your element is present in the sorted part, means right side of the middle, or not right side, you can say in the sorted part. Okay, so now let's do the finding in the sorted part. Now, we will find out the element in the sorted part by using binary search, because the part is sorted and we need to find out that element. So this is nothing but a simple binary search problem. We need to find 11 in this sorted part, this element index 2 3 4, this. So this is nothing but a binary search. You just need to find out 11 in the part of the sorted array, and here start is equals to 2 and is equals to 4. Okay, you just find out this in the sorted part. That's it. Okay, let's find out uh, whether that element exists in the sorted part or not. Okay, okay, so you apply binary search here. Start is your mid, middle is element is 2, start is 2, and is your the end index which is 4. Okay, now again find out middle here. Middle is equals to your 2 plus 4 by 2, which is equals to 3. Okay, now your middle is this. Now it means that you are here at index 3. Okay, now again see 10. Okay, now middle is your 3. Now see this. Again you have to reiterate that approach, that whether that 10, now see, you compare 10 with the start element is index 2, which is 6, and 10 is greater than 6. 10 is greater than 6, it means that this part is sorted. Okay, and 10 is less than 11, so it means that this part is sorted. So it means that both parts are sorted here. So as I said that at least one of the two parts will be sorted. So in this case both are sorted. Okay, so no need to worry. So you need to find out 11. Okay, now what you do, you just check your 11. So your 11 is less than your middle element or greater than middle element. Okay, so as in this case 11 is greater than middle element. Okay, so you need to go to right side because the part is sorted. Okay, so you need to find out whether the element is greater than 11, greater than 10, or less than 10, because both parts are sorted. So 10 is great, 11 is greater than 10, so you need to go to right side. So you just go right side, and in right side you can see what you need to do. You need to change this. Your start will become mid plus 1. Okay, because you need to go right side, right? So start will become mid plus 1, this one, and and will be same, and will be your 4. Start will be your 4. So 4, so mid will become 4 plus 4 by 2, 8 by 2, that is equals to 4. This is the mid. Okay, now you just compare whether it is equal to target. This is equal to target. Okay, so here you will return this index 4. Okay, so in this way you can find out whether that element is parent or not. So here we saw that the element is present in the sorted part, which is 11, this one, this part. Now let's see, we need to find 100. Okay, 100. So we need to find whether that element is present or not. Now here our target is 100. Okay, now let's see. So here that element which we need to find, that is present in the unsorted part, because this is sorted part, this is unsorted part. Now the approach will be same. First we need to find out the mid element, and the mid will become same here, which is equals to index 2, and index 2 is your 6, middle is 6. Okay, next you need to see whether the 6 is, next step is you need to compare middle with start. Start is your 0, which is means 100. So and is your index 4, which is 11. Okay. Now 6 is less than 100. Yes. So it means this part is unsorted. Next, 6 is less than 11. So it means this part is sorted. Okay. Now let's see whether this parent is this part or this part. Okay. Now we need to see such 100. Okay. So if this part is sorted, okay, this part is sorted, right? Now we can see, we can compare our 100, this one, the thing which we need to find out, with the value present in this index, last index, because that will be the highest value, right? So we compare 100 with 11. 100 is greater than 11. So it means that definitely this element is not present in the sorted part, right? Because if this present is sorted part, then definitely there will be 100 exist, or any element greater than 100 exist. That's because that's the way this is sorted array, right? But the highest value is 11, and we need to find 100 definitely, and this part sorted. So it means that 100 is not present in this part. Okay, so we got the idea that this 100 will definitely present in the left part only. So in this way, we are pruning our search in one part only. So we don't need to search in this part. We need to search in this part only, right? That's the how we can use binary search here, because we are because I said one of the two parts we sorted. So in the sorted part, I compared with the last element, which is the highest, with the target, and target is greater than that. It means that definitely that element not present in the last in the sorted array. So it means it is present in the unsorted array. Now we need to come find out this in the unsorted array. Okay, and then we can find in the unsorted array. So in this, what becomes, our start will be, start is 0, mid is equals to 2. Now here what will change, our end will change, because we need to go to the left, we need to go to the left, right? So our end will become mid minus 1, mid is equals to 1. So start 0, mid to end 1. Okay, this is the now. So now our start is 0 and end is 1. So start is 0, end is 1. Now we find out the middle element. Middle is 0, 0 plus 1 by 2, which is equal to 0. This is the middle element. And now we compare with the 100. So 100 equals to 100. It means that we got the index. Okay, that we got that element. So this is how we can do it. Okay. Okay. So till now, if you have any doubts, you can ask in the comment section. Okay, so let's see how we can do it. Okay, so let's first we will do a quick run that what we have done till now. So first we find out, first we discuss the problem statement. Okay, and then we discuss that what exactly the problem is with the problem sample test case, and then we discuss the solution of this problem by using brute force solution, which is the order of n time linear search solution. Okay, which is giving order of n time. That's why it is taking uh, TLE, because that will be giving you a time limit exit error, because the test cases are very high here, so you can't do that. So now we discuss the next approach, which is the binary search approach. Okay, so in this binary search approach, we discussed how we can do this by using this array. like if we need to find out that element is present in the sorted part or the unsorted part, and at least one of the two part will be sorted, as I said. So like if that element is present in sorted part, then we just do the binary search. If it is present in unsorted part, again we can do, but we will do search in one part only, not in both the parts. Like first I told you, if suppose we need to find an element which is present in unsorted part, then we compare this element with the uh, last element of sorted part, because that will be the end element, right? And we can see whether that element exists or not. So here 100 is we need to find out, and 11 is the last element. So we get to know that this element is not present in sorted part, right? So it means that it is definitely present in the unsorted part. So in unsorted part, we move to left, and then we compare in this unsorted part, and we get that 100 is present here. So this is how we have done. Okay. So in this, we need to find out whether that element present in sorted part, unsorted part, but we don't need to find out in both the parts, right? So we need to find either in left part or in right part, but not in the both the parts. That is how the approach of this problem is. Okay, that's why uh, it will work, because if you scan the whole array, then it will become a linear search. Okay. Any doubt? Okay, fine. Let's discuss the approach then. Okay, so the input is 25 minus 30, 25 minus 30. Okay. Okay, so we need to find out the element. Suppose we need to find out 5. Okay, first we see the middle element. Middle is your 0 plus 3 by 2, which is equals to 1. So here we get middle is 1. So here we directly get that middle element is equals to target, and target is 5. So we can directly return the index, which is 1. Okay, so no need to worry in this. Next, let's take another case. 25 minus 30. 25 minus 30, and suppose here we need to find out whether minus 1 2 3, okay, whether minus 3 exists or not. Okay, so first we will do middle element. Middle is your 0 plus 3 by 2, which is equals to 1, which is 5. Now this middle element is 5. Now we need to compare the middle element with the start is 2, middle is 5. Now 5 is greater than 2, it means this part is sorted definitely. Okay, and now and we start with the middle. Now we compare and with the middle. And is your 0 and middle is your 5, and 5 is greater than 0. Definitely it means that this part is unsorted, because if this part is sorted, then definitely element after 5 will be greater than 5, but the element after 5 is lesser than 5. It means this part is unsorted and this part is sorted. Okay, so this part is sorted and this part is unsorted. Now we need to see that element exists or not. Okay, so uh, left part is sorted. Now index is start, and the need to find minus 3. Let's see. Minus 3 minus 4. Okay, so the middle is 1, index is 1, start is 0, and is 3. Now what we'll do, we need to find minus 3. Okay, now this part is sorted. Okay, so we compare our element with the sorted part. Element we need to find out minus 3. If this part is sorted, definitely our element should lie in this part, right? If this part is sorted, this part sorted, and if that our element which we need to find minus 3, it should lie in this part. It means that minus 3 should be greater than equals to 2 and minus 3 should be less than equals to 5, right? Then only minus 3 comes in the left part, in the sorted part. That's how it come, okay? Because if this minus 3 comes in sorted part, then it should satisfy this criteria, because it will be in increasing order, right? We know sorted order. But minus 3 is greater than equals to 2. This is false only. This is false. It means that our element is not present in sorted part. So we need to find out the element in the unsorted part. That's it. So what we will do, we will shift to right side. We will just do start is equals to mid plus 1. So now our start will become 2 and our end will be end is 3 only. So now our mid will be 5 by 2, which is equals to 2. And now this is our mid, and we compared mid with the target, which is minus 3. So we get that element 2. Okay, this is how we have done. So what we have done, first we find out which part sorted, and then we compare our element with the in that sorted part, whether that element exists in sorted part or not. Okay, this is how we can done. And if that element exists, then we can find in sorted part, else we find out in unsorted part. Okay, that's how we can do it. But we need to find in sorted part only. That's the main thing. Okay, we need to find in sorted part only. Okay, so let's do the approach algorithm for this question. Okay, so suppose you have this one. Okay, so the question is 25 minus 30. Okay, 25 minus 30. Okay, so first you find out whether that element exists or not. So first you just find out middle. Middle is equals to 0 plus 3 by 2, which is equals to 1. Middle is 1, right? That's not an issue. Middle you find out 1. Next you need to find out which part sorted. Okay, now you need to compare your middle with the start. As I said, which you need to find out which part is sorted. So you compare your middle element, which is 5, with the start. Start is 2, middle is 5, 2 is uh, 2 is less than 5. It means definitely this part sorted. Okay, this part is sorted definitely. Okay, now this part sorted. Now we need to search in sorted part only, right? What we will do, we will compare that element which we need to find. Target is minus 3. We will compare this. We will compare that if is your minus 3 lies in sorted part or not. How we can compare? Is minus 3 greater than or equals to starting element, which is 2, and is your minus 3 less than or equals to left side ending element. Left side ending element is 5. That's how minus 3 exists in a sorted array, right? Because if minus 3 exists, then it should satisfy this criteria. But it is not satisfying. It means that it is present in the right part only, in the unsorted part. Okay, so we do start is equals to mid plus 1. That's it, simple. And okay, and then your mid become this one, and you return this. Okay, and let's suppose you need to find out 2. Okay, let's suppose you need to find out 2 in this. So in this problem, our element is present in sorted part only, which is 2. In previous case, I told you the element present in unsorted part, which is 3 minus 3. Okay, now the middle will become same. Middle is your 0 plus 3 by 2, which is equals to 1. Okay, now 5 is equals to target. Target is 2. 5 is not equal to target. Okay, now you need to find out which part sorted. Now compare start with the middle. Now start is less than middle. It means this part sorted. Okay, this part sorted. Now you find out whether your element exists in this part or not. Now if your element exists in this part, then your element, which is target, should be greater than or equals to starting element of that part, and your element should be less than or equals to ending element of that left part. This is this one, and this is completely satisfying this criteria, right? 2 is greater than or equals to 2, and 2 less than or equals to 5. It means it is present in left part only. So you just go where go? You need to go to the left part, right? Because this time your element present in left part, not in the right part. So what you do need to do? You need to do end is equals to mid minus 1. That's it. Now your end will become your mid was 1. Mid was previously, but your mid was previously 1. So 1 minus 1 0. End becomes 0. And start was already 0. Haven't touched start, right? Now you find out mid. Mid is equals to start plus end by 2, which is equals to 0 0. And you compare that to element with your target. And this is your answer. Okay, so this is how we can do it. Let's code this problem, and then I will tell you how it is done. Okay, so initially what we need to do, we need to first find out the middle element. Okay, so first we start is equals to 0 and is equals to last index of that element of that array. Okay, start is 0 and is your last element. Now you need to find out, you need to apply binary search. Okay, how you apply binary search? You will find out mid. Mid is equals to start plus and minus start by 2. Okay, now mid, you get mid. Now you first compare if your middle element only is equals to a target element. If this exists, means you find out the element. Your middle element only is target element, then you return that just middle element index. Okay. Else, now you need to find out which side is sorted, right? Which side is sorted, because you need to find out that in sorted part only. Now, so let's suppose left side is sorted. Now we are searching whether left side is sorted. Now how to check left side sorted or not? If your left side sorted, then your element, which is your middle element, it should be greater than and equals to your starting element, right? If your left side is sorted, then your middle element should be greater than equals to, right? Because middle coming after the start. So your start is basically on the start, and then middle is basically after start. So your middle element should be greater than equals to the starting element. Okay, that's how it can be done, right? See, so this is the array, right? 2 5 minus 3 0. Now, if this part is sorted, this is your middle. Your middle should be greater than or equals to starting element. Then only this part is sorted, right? Because if it is sorted, then middle is coming after start. So it should be in increasing order. That's fine. Okay. Okay. So if suppose this part is sorted, okay, means left side sorted. Now we need to check whether our element exists in that sorted part or not. As I told you, we need to check whether our element exists in sorted part or not. So we need to checking whether element exists in sorted part. Sorted part. How we can check? We just need to compare, because if our element, which is target, is present, if it is present in sorted part, it should be greater than equals to the starting element of that sorted part, as well as it should be less than equals to ending element of that sorted part, right? That's how it will be in that sorted part, right? As I told you previously, if that element exists in sorted part, it should be greater than equals to start and less than equals to array of mid, not end, because the end side of the left array is the middle element, right? Because end is the last element, and your left, you need to find in the left side. So middle element in the left side should be the end value. Now, if this is true, means your element exists in the left side, then you need to shift to left. What you need to do? You need to do end is equals to mid minus, right? You are shifting to left because that element exists in the left side of the array. So you are shifting to left. Else, else means here we are checking that element is not present in the sorted part. So it means that that element present in unsorted part. As I told you for the minus 3, that the element is present in unsorted part. Like this one. That element is present in unsorted part. So you need to go to the right side. Okay. How you can check? So if it is not coming in the if, then it means definitely it is in the right side. Now, if it is in the right side, you need to shift your middle to the start plus. Shift your middle to the shift your start to the mid plus, because now your search space reduces to this one only, this one, right? So your end will be this only, this is the end. Now your start will become this, right? Search space reduces to right side. Okay, that is the first thing, that your left side is sorted. Now you same you need to do for the right side, because you don't know which side is sorted here, right? As I told you, this is a partially sorted array, and you don't know which side sorted. So you need to check whether left side sorted or right side sorted. Okay. Now, here you have, here you checked left side sorted. Now, yeah, now here you are checking whether the right side sorted or not. Now, if your right side sorted, then the middle element should be less than equals to your ending element, right? Because if your right side is sorted, middle element, it should be less than your this element, right? Then only it is sorted, right? As you can see. Suppose this is your middle. it is less than the ending element. It means that this part sorted. But if your middle element is not greater than the if your middle element, this one, this is middle, if it is not greater than the light end part, then it means that this is not sorted. Okay, so this is how you can check whether the right side is sorted or not. Okay, now, so if right side sorted, then you need to check whether your element exists in the sorted part or not. So you need to check if key is greater than or equals to array of start and key is less than or equals to array of mid. Okay, so you are checking whether the element exists in sorted part or not. Or you can check, so it is present in the right side sorted. In the right side, you need to compare your key with the mid and well as with the end, right? Because if this part is sorted, as you can see, this part is sorted, then your key should be greater than equals to greater than equals to this one and should be less than equals to this one, right? Then only it will be in this part, sorted part, right? So you have checked greater than equals to mid and less than equals to end. If this is the case, then you are shifting your start is equals to mid plus one because you are going to the right side. So you are shifting your start to mid plus one because you are going to right side. But if your element is not present in the sorted part, then you have to shift your search space to the left part. Here you have to do end is equals to mid minus one. Okay, and in the end, you just return that index. You are returning index here only. Okay, and in the end, if you didn't find out, then you return minus one. And this you have to do this in while loop because this will be happen till start is less than equals to end. This is basically the binary search, right? You need to do this till start is less than equals to end. Okay, now let's check whether it is running. So it is giving error at 22. Okay, 34. So it is giving runtime error. Okay, let's see what is the problem. Array index out of bounds, exception at 12. It is giving at 12. Okay, start is 0 and is array dot length. It will be minus 1 because you need to do this. Last element will be the end. So it should be array dot length minus 1. Let's see this. Now it is correct answer. Let's submit. Okay, so it is running correctly fine. Okay, so what you have done, again I told you. So first you find out this is your 25 minus 30. Okay, suppose you need to find out in the 2, you need to find out target is equals to 2. So first you need to the middle is this one. Now you need to first check whether left side sorted or right side sorted. So here in this case left sorted. Now you need to check whether your element present in the this is sorted. Okay, now you need to check whether your element present in sorted part or not. So it is present in sorted part, so you find out here. Now suppose target is minus 3. So you first check, this is middle element. Now you first check left sorted or right sorted. So left sorted, okay. Now you check whether your element present in sorted part or not. So here in this case, minus 3 is not present in sorted part. So it will definitely present in the unsorted part. So you check here. So in either of the case, whether it is in the sorted part or unsorted part, you are pruning your search to one part only, not the both the parts. That's how it will be reduced to one side only. So that's why it is binary search we have used. And the complexity is order of logarithmic of n because we are in each iteration we are scanning the dividing the array into half of part, right? We are cutting down the half parts. So this is how we can done. Okay, so this is the time complexity of this algorithm, and the space complexity is order of one. Okay, so if you have any doubts, you can ask in the comment section. So if you have any doubt, you can ask, because that's the end of the stream, because that is the only question we need to uh, do here. So the complexity is log n, because we are reducing our search space to half parts each time. As I told that first, uh, we searched in the, yes, 2 5 minus 3 0. Okay, so this is the middle element. Now we need to search only either in this part or in this part, right? We are not searching both the parts. As I told that if our element is present in the sorted part, then it will search in this part only and this part will be pruned, right? Or else if our element present in the unsorted part, then it will be in the this part only and this side will be pruned. Okay, so in each iteration we are reducing our arrays to half each time, and since we are doing to half each time, so it will be log base 2 of n, where n is the number of elements in the array. So that's how it will be order of logarithmic complexity, and that's why it is working here, because the test case are high. So normal order of n approach will not work here. So it will work for the order of logarithmic approach. Any other doubts? Okay then. If you have no doubts, then that's the end of the stream. Thank you very much. If you have any doubts, you can ask in the comment section. So that's all about this. Thank you very much.